All right, today we're going to continue talking about proving trigonometric identities. So a little reminder of our identities. We have our Pythagorean identities, our reciprocal identities, and our quotient identities. All right, so we have another strategy to help us solve these. The third strategy is to try and set up some sort of the Pythagorean identities to create these squares so that we can simplify things. So always be mindful of your target expression, what you're trying to get your equation to look like. And then another strategy is to work from both sides. Simplify the left side as far as you can, and then sometimes you can't get it to equal the right side, so then maybe start simplifying the right side, and hopefully you can get the left side to equal the right side. All right, so we want to prove the identity on cosine of t, which I'm going to use x if you guys don't mind, over 1 minus sine x equals 1 plus sine x over cosine x. So what I'm going to do is I'm going to take this side and I'm going to create a difference of squares on the bottom. So if I multiply by its conjugate, 1 plus sine x, but I have to do it to the top. So on top, I'm going to get cosine x plus cosine x times sine x over, this is going to be difference of squares, so it's going to be 1 minus sine squared x. Alright, so then I can on top factor out a cosine. So if I factor out a, well, that was silly, I just distributed it in. Sorry, if I factor out a cosine, I'm going to end up with 1 plus sine x, which is what I had before I distributed. Silly me. This I can replace with cosine squared x, because 1 minus sine squared x equals cosine squared x. And now one of these copies of cosine on top will cancel one of the two copies on bottom, which leaves me with 1 plus sine x over cosine x, which is what I was trying to get, so I win. Alright, so let's solve this one. Alright, I see that 1 plus sine b on the bottom, so I'm going to again make that and try and create a difference of squares on the bottom. So I'm going to multiply by 1 minus sine b on top and bottom. So on top, I'm going to have cosine b times 1 minus sine b over 1 minus sine b squared. Sine squared b, sorry. Right, because that's going to be difference of squares. So again, I can replace that 1 minus, like this, cosine b times 1 minus sine b over, I can replace 1 minus sine squared with cosine squared again. And then one of your copies on top will get rid of one of them on bottom. And I end up with 1 minus sine beta over cosine beta, which is what the other side was. I win. Okay. Alright, so if we try this one, same thing. I'm looking at the bottom and I'm thinking difference of squares. So if I multiply by, I don't have enough room. Alright, if I take this one, tan squared x over secant x plus 1, I'm going to multiply by its conjugate to create difference of squares, so secant x minus 1, but I got to do it on top and bottom. Alright, so now on top, I'm going to have tan squared x times secant x minus 1. On bottom, that's going to become secant x squared, secant squared x, sorry, minus 1. Secant squared x minus 1 can be replaced with tangent squared. So this becomes tan squared x times secant x minus 1 over tan squared x. Alright, which then these two will cancel, and that gives me secant x minus 1, which is not what the other side is. So let's see. I can take this and rewrite secant x as 1 over cosine x minus 1. Then if I get a common denominator, cosine x, I would have 1 over cosine x minus cosine x over cosine x. So now I can keep the denominator, cosine x, and on top would be 1 minus cosine x. That is the other side. I win. Okay. Alright, so we have this one. Alright, prove this identity. We have cotangent squared u over 1 minus or plus cosecant u. So I'm going to start on this side and see how far I get. I can tell from this I'm going to have to work from both sides. So let's see, we're going to start with cotangent squared x over 1 plus cosecant x. I'm going to try that difference of squares thing again. So I'm going to multiply by 1 minus cosecant x on top and on bottom. And that gives me cotangent squared x times 1 minus cosecant x over 1 minus cosecant squared x, because that would be difference of squares. So now I can replace, this one's kind of tricky. Alright, I need a 1 minus cosecant squared, and I don't have that. I have cosecant squared minus 1. So we're going to do that -1 trick. Alright, I can multiply this bottom by -1. Right, and I get cotangent squared x times 1 minus cosecant x. If I factor out a -1, I'm going to get -1 plus cosecant squared x, which now you can say cotangent squared x times 1 minus cosecant x over -1 times, this now is cosecant squared x minus 1, and cosecant squared x minus 1 equals cotangent squared. So I can replace that with cotangent squared x now. Alright, so these would cancel, and I end up with 1 minus cosecant x divided by -1, which is going to give me -1 plus cosecant x, which gives me cosecant x minus 1. And there's really nothing else I can do. So that would be my left side as far as I can go. Alright, in other words, I can't make this look like that. So now I'm going to switch gears and try working from the right side and see if I can't get that to simplify down to this. So I'm going to take cotangent u times secant, oops, I'm going to use x's again, sorry. Cotangent x times secant x minus tan x. If I distribute that, I get cotangent x times secant x minus cotangent x times tangent x. If I rewrite everything in terms of sine and cosine, cotangent is cosine x over sine x. Secant x is the same as 1 over cosine x minus cotangent x again is cosine x over sine x times tan x is sine x over cosine x. So now if I cancel, this cosine cancels this, and I'm left with 1 over sine x. This cosine cancels that, this sine cancels that, so that leaves me with 1. Alright, and then if I replace 1 over sine x with cosecant x, I get cosecant x minus 1. So I simplified the right side to the same thing as the left side, so I win. Alright, So it says in most calculus problems where identities play a role, the object is to make a complicated expression simpler for the sake of computational ease. Occasionally, it is actually necessary to make a simple expression more complicated for the sake of computational ease. Each of the following identities, just a sampling of many, represents a useful substitution in calculus wherein the expression on the right is simpler to deal with even though it does not look that way. We prove one of these identities in example 6 and leave the rest for exercises or for future sections. Alright, so we are going to prove this one, okay, which was that last one on the list on the previous page. Alright, so what I'm going to do is I'm going to take this, alright, and I'm going to rewrite cosine of the fifth x as, I can rewrite that as cosine squared x times cosine squared x times cosine x. That would be cosine squared times squared is to the fourth, to the first would be altogether cosine to the fifth. Okay, why would you want to write that, miss? Well, I'm going to try and get, I see all these signs over here and only one cosine, so I'm going to rewrite this cosine squared x as 1 minus sine squared x, and I'm going to rewrite this one as 1 minus sine squared x, and I'm going to leave this one alone, times cosine x, yes? So I'm going to multiply these two out. So I would have let me switch colors. I would have 1 minus sine squared x minus sine squared x plus sine to the fourth x. If I combine like terms, I get 1 minus 2 sine squared x plus sine to the fourth x. And I still have my sine squared x factor and my cosine x factor. Okay, so then if I distribute this sine squared, I get sine squared x minus 2 sine to the fourth x plus sine to the sixth x times cosine x. And if you look, there's my other side. I win. Okay? Alright, next we're going to prove this identity. Alright, I'm going to take this side and I'm going to rewrite cotangent squared x as, where am I? Cotangent squared x, right here. So I'm going to rewrite that as cosecant squared x minus 1. Alright, so now if I distribute, I get cosine squared x times cosecant squared x minus cosine squared x. If I try and write everything in terms of sine and cosine, this would be cosine squared x. This would be 1 over sine squared x minus cosine squared x. This then becomes, if I multiply the tops and the bottoms, this becomes cosine squared x over sine squared x minus cosine squared x. This cosine over sine is cotangent, so cosine squared over sine squared would be cotangent squared x minus cosine squared x, and that, my friends, equals the other side, so I win. Alright, so if we prove this one now, alright, on this one I'm going to take this side and I want to get a common denominator. So if I have, I'm going to multiply this by sine t and the top, and this side I have to multiply by 1 minus cosine t. So that common denominator is going to be sine t times 1 minus cosine t. On top, we're going to have sine squared t. And over here, we're going to have, that's going to be difference of squares, so that's going to end up to be 1 minus cosine squared t. Alright, so now if I rearrange the top, no, not rearrange the top, on this one, I can rewrite that sine squared t as 1 minus cosine squared t plus 1 minus cosine squared t over sine t times 1 minus cosine t. Alright, and then at this point I can combine like terms. So I have 2 minus 2 cosine squared t over sine t times 1 minus cosine t. Alright, if I factor out a 2 on top, that would leave me 1 minus cosine squared t. On bottom, I'm going to get sine t times 1 minus cosine t. If I take factor that top difference of squares, that becomes 1 plus cosine t times 1 minus cosine t over sine t times 1 minus cosine t. The 1 minus cosine t's cancel, and I end up with 2 times 1 plus cosine t all over sine t, which is the other side of the equation. I win. Alright. So if we try this one, alright, I'm going to take this side and I'm going to start simplifying it. So, I don't know, the first thing I see, a whole bunch of sines and cosines on this side and a whole bunch of tangents on the other. So my instinct tells me to rewrite everything with sine and cosine. So I'm going to rewrite tangent A as sine A over sine B. Yeah, sine A over, no, cosine A, sorry. Plus, for tangent B, that's going to be sine B over cosine B. And on bottom, I'm going to have 1 minus sine A over cosine A times sine B over cosine B. Alright, so now if I get a common denominator on top, which will be cosine A times cosine B, so I'd have to multiply both top and bottom by cosine B here, and top and bottom by cosine A here. So on top, that's going to give me, well, I can keep the denominator now, which is going to be cosine A times cosine B. And on top, I'm going to have sine A cosine B plus sine B cosine A. Alright, now where am I going to go from there? Well, on the bottom, now I have to fix the bottom. Over here, I need, let's see what I got. Okay, this is going to be that, right? So I need a common denominator over here of the same thing, which will be cosine A cosine B over cosine A cosine B, that's still 1, minus sine A sine B over cosine A cosine B. So now I can keep that denominator, which is cosine A cosine B. And on top, I have this mess, cosine A cosine B minus sine A sine B. So now I have this on top and this on bottom. So I'm going to keep, change, flip. So I'm going to have sine A cosine B plus sine B cosine A, I'm going to have sine A cosine B plus sine B cosine A over cosine A times cosine B times, flip that one, I have cosine A cosine B over cosine A cosine B minus sine A sine B. And now those will cancel and I end up with sine A cosine B plus sine B cosine A over cosine A cosine B minus sine A sine B. And that looks like that, so I win. Okay? Alright. We got this one going on. This one's actually pretty simple. I'm going to rewrite my cosine cube, so I'm going to leave sine cubed x, but I'm going to rewrite cosine cubed x as cosine squared x times cosine x. Alright, then I'm going to replace cosine squared x with 1 minus sine squared x times cosine x. I'm going to distribute the sine cube, which gives me sine cubed x minus sine to the 5th x times cosine x. And that looks like the other side, so I win. Okay. Alrighty, so now hold on just a second. Alright, so now we have, sorry, I'm just checking my signs here. Alright, this one's a long one. Oops. Sorry, hold on. I hit a button. There we go. Alright, so what I'm going to do here is I'm going to multiply. Let's see what I'm trying to do here. Why am I doing this? Well, I'll get a different color. I work these out ahead of time because they can get quite complicated and I always forget how I solved them. And now I'm trying to figure out why I did what I did. Alright, so I took this one and I multiplied the top and the bottom by sine x. Well, actually, first thing I'm going to do is I'm going to rewrite everything in terms of sine and cosine. Because I look at this side and I see that they want it in terms of secant and cosecant, which are the reciprocals to sine and cosine. So, first of all, if I take tan and I rewrite it as sine x over cosine x, and on bottom I have 1 minus cosine x over sine x, plus cotangent x would be cosine x over sine x, over 1 minus sine x over cosine x. So now what I did was, I didn't know what I did, or why I did it. I'm looking at my work and I'm thinking there's got to be a shorter way to get that. I'm going to try something different than the way I worked it out. Alright, if I look at the bottom here and I get a common denominator, that would be sine x. So I can rewrite 1 as sine x over sine x instead of 1. So that would give me sine x over cosine x over sine x minus cosine x over sine x. And over here, if I get a common denominator, that would be cosine x over cosine x would still be 1. That's going to give me cosine x over sine x all over cosine x minus sine x all over cosine x. And now, if I flip both of these, I would keep the sine x over cosine x times sine x over sine x minus cosine x, and that gives me sine squared x over cosine x times sine x minus cosine x. And let's see what this one does. If I keep cosine x over sine x, change, flip cosine x over cosine x minus sine x. This isn't going to give me any good, is it? That's going to give me cosine squared x over sine x times cosine x minus sine x. Yeah, that's not doing me much good. Well, this is what happens when you prove trigonometric identities. Sometimes you get yourself stuck. I don't really know where to go from here. So I'll back up and do it like I did, and maybe that's why I had to do it that way. Alright, let's start this thing over. For whatever reason, not really sure why, maybe it'll become clear in a minute, I multiplied the top and the bottom of this by sine x. So that would give me sine x times 6. That would give me sine x times sine x over cosine x, if I change tan. And on bottom, I'm going to have sine x minus sine x times cosine x over sine x. So if I simplify that mess, this on top becomes sine squared x over cosine, and the bottom becomes sine x minus cosine x. Alright, and so now if I do the other side, or the other fraction, I'm going to multiply both of the top and the bottom of it by cosine x. So that would give me cosine x times cosine x over sine x over cosine x minus cosine x times sine x over cosine x for tangent. Okay, that's going to give me cosine squared x over sine x all over, those cosines cancel, and I get cosine x minus sine x. Alright, so now I need to get a common denominator, which they almost match except for they're backwards. So I'm going to do the -1 trick. Alright, and if I factor out a -1, I'm going to have I do it on top and bottom, that's going to give me a negative sine squared x over cosine x over this will make this negative and this positive, which will make it cosine x minus sine x plus cosine squared x over sine x over cosine x minus sine x. Now they match, so I can keep that denominator, cosine x minus sine x, and on top I'm going to have, negative sine squared x over cosine x plus cosine squared x over sine x. Alright, so now what am I trying to do? Okay, so then what I did was, I need to get a common denominator on top. So I'm going to have to multiply by sine x, and cosine x, and cosine x. And that's going to give me sine cubed, negative sine cubed x over sine x cosine x plus cosine cubed x over sine x cosine x all over cosine x minus sine x. So now on top I have cosine cubed x. I'll put the positive one first. Cosine cubed x minus sine cubed x all over sine x cosine x all over cosine x minus sine x. Now if I keep, change, flip, I'm going to keep this top one and I'm going to flip this one to be 1 over cosine x minus sine x. Yeah. And then if I factor, that's going to give me cosine cubed x minus sine cubed x all over, sine x times cosine x times cosine x minus sine x. So now if I factor the top, which is difference of cubes, which I don't have any more room to do, darn it. Alright, I'm going to have to erase some, sorry. Darn it, that's not going to look good, is it? Alright, so, yeah, darn it. So if I factor the top, that's going to be cosine x minus sine x. And then you square them, so this will be cosine squared x, and this will be sine squared x. And the two signs are plus plus, because it goes minus plus plus, and then you multiply them together in the middle, which gives you cosine x times sine x. Alright, and then I'm going to, that's all over sine x times cosine x times cosine x minus sine x. Now those will cancel, and I'm left with cosine squared plus, I can rewrite this, so I'm going to put this in this order. So I have cosine squared x plus sine squared x plus cosine x times sine x all over sine x times cosine x. This is 1, so that's going to be 1 plus cosine x times sine x over sine x times cosine x. And then that, dang it. This I can write as 1 over sine x cosine x plus cosine x sine x over sine x cosine x. This cancels, so I'm left with 1 over sine x cosine x plus 1. Okay, this is 1 over sine times 1 over cosine plus 1. that 1 over sine is cosecant x, 1 over cosine is secant x plus 1. And I can write that in any order I want, so it's the same thing as 1 plus secant x times cosecant x. That's the other side, and I finally win. Alright, that was a doozy. Alright, so now we are going to have the secant to the 4th x. So what I'm going to do is I'm going to start with this side and I distribute, and that's going to give me secant squared x plus, this is going to give me secant squared x times tan squared x. I'm going to rewrite everything in terms of sine and cosine. So this would be 1 over cosine squared x. This would be 1 over cosine squared x. This would be sine squared x over cosine squared x. So that gives me 1 over cosine squared x plus sine squared x over cosine to the 4th x. Alright, I need to get a common denominator, which is going to be cosine to the 4th, so I'm going to multiply both sides by cosine squared x. That gives me cosine squared x over cosine to the 4th x plus sine squared x over cosine to the 4th x. Keep the denominator, cosine to the 4th x, and on top I have cosine squared x plus sine squared x, which we all know is 1. So I have 1 over cosine to the 4th x. Well, 1 over cosine is secant, so 1 over cosine to the 4th would be secant to the 4th x. And that's the other side, so I win. Alright. And we are at homework, which means we are done. Happy homeworking, and I will see you next time.